Good morning, everyone. Today we will see dynamic programming. This is a strategy for solving problems. Next, we will see how to solve problems using dynamic programming and what are the approaches available in dynamic programming for solving problems. Dynamic programming is a problem solving method used in computer science field to solve complex problems by breaking them into simpler and overlapping subproblems. If the problem is too complex or too big, we can divide the problem into a number of subproblems. And the subproblems can be solved, that results can be stored in a table that can be reused in a dynamic programming approach. Overlapping subproblem means that the subproblem occurred more than once. We can use dynamic programming concept. The subproblem, if occurred more than once, the problem can be solved once and the result is stored in a table that can be reused whenever the same subproblem occurs in the solution space. It is mainly used for solving optimization problems. Optimization problem means objective is to maximize or minimize the objective values. There are two types of optimization problems, maximization problems or minimization problem. In the case of maximization problem is the objective function is to maximize the value. For example, profit, knapsack problem, we are finding most valuable subset. And minimization problem, finding the shortest route in traveling salesman problem. The cost should be minimized or the time should be minimized. So to solve these type of optimization problem, we can use dynamic programming concept. Here mainly it uses recursive structures. The core idea is to solve each subproblem only once and store the redundant results to avoid redundant computations or calculations. So by applying dynamic programming approach, the problem can be solved in efficient manner. And subproblems. A complex problem is divided into small number of subproblems that is easy to solve individually. Next, optimal substructure. The optimal solution for main problem can be built from an optimal solution of subproblems. If we are getting optimal solution for subproblem, then we can derive that will lead to a optimal solution for whole problem. And overlapping subproblems, instead of solving the same subproblem again and again, we can apply dynamic programming approach. Memorization. What is the memorization? The result is stored in a table or a memory that can be reused when the subproblem occurred second time. So that is the time complexity is reduced. So these are the four key components in dynamic programming: subproblems, optimal substructure, overlapping subproblems, and memorization. And what are the approaches to solve problems in dynamic programming? Top-down approach uses memorization, and second one is bottom-up approach using tabulation. In the case of top-down approach, we are using recursive algorithms. The complex problem is divided into number of subproblems and the problems are solved recursively. If the problem occurred more than once, the results are stored in a table or cache memory. So this technique is to catch the result of expensive function calls. So when the function call is called with the same input again, the cached results are returned, avoiding recomputation. So we have multiple recursive call with the same value. So if the recursive function is already solved, that results can be reused instead of calculating again. That is called top-down approach, memorization. Second one is bottom-up approach. Here we are taking the base case. We are solving the base case initially. Then it use iterative approach, looping statement. Iterative approach to build solution from base case to the whole solution. Usually it uses array or table. It refers to filling a table in a systematic manner to avoid recursion. A problem results are stored in a table, so each is computed only once. So there are two types of approach: top down, that is memorization; bottom up, tabulation. Top down, it use recursive calls. Bottom up, it use iterative calls. And first, we will see what is top down approach. This is a memorization. I will explain with an example. So the problem is to finding nth Fibonacci number in a Fibonacci series. The Fibonacci series always starts with 0 and 1. Initial value is 0 and 1. Then the next third number is calculated as sum of previous two numbers. That is Fibonacci of n equal to Fibonacci of n minus 1 plus n minus 2. Nth term is sum of n minus 1th term and n minus 2. That is where n should be greater than or equal to 2 because we are assigning initial value to first two terms 0 and 1. See the diagram. Here is the recursive call. This representation of recursive call. The input is 6. Now we are going to find sixth term in the Fibonacci series. So how it can be split as two recursive calls. Here we are having two recursive calls, Fibonacci n minus 1, Fibonacci n minus 2. So Fibonacci of 5 and 4. Again Fibonacci of 5 divided into two subproblems 4 and 3. Again 4, 3 and 2. Like that it is divided recursively till we have Fibonacci of 1 and 0 till base case. Till base case from the computing case to base case. Here base case is Fibonacci of 0 is 0. Fibonacci of 1 is 1. That is 0th term and 1th term. See the recursive call, all leaf nodes are Fibonacci of 0 or Fibonacci of 1. Now, see the subproblem, the left side, Fibonacci of 4, that's the left circle. It's a one-time subproblem that will be solved in the left side. And the right side, blue circle, Fibonacci of 4, the same subproblem occurred twice. Here, in this approach, top-down approach, first time the Fibonacci of 4 result is stored in a table. Again, if the problem solution space has the same problem, subproblem, Fibonacci of 4, the results are reused. Instead of executing the problem again and again, the results are reused. Here is the Python code to find the nth Fibonacci number in the Fibonacci series. So we have the function called fib. This is a recursive function. If n is memo, that can be a catch. If the subproblem results are already stored in a table, return the result. No need for recomputation. If n is less than or equal to 1, it's a base case. 0 means 0, 1 means 1. Return memo of 0 and 1. Else, here we go to Fibonacci recursive call. Memo of n is equal to Fibonacci of n minus 1 comma memo n minus 2. This recursive call with memorization. Return memo. So if the input is Fibonacci of 10, it performs recursive call. The output it returns 55. This is an example for top-down approach in dynamic programming to find the nth Fibonacci number in the Fibonacci series. And how it works. For example, start Fibonacci of 6. It depends on Fibonacci of 5 and 4. And the function recursively breaks the problem into smaller subproblems. Each result is stored in a table. The future calls reuse the value instead of recomputing. Reusing instead of recomputing. That is the main advantage of top-down approach in dynamic programming. So the time complexity is Tn of is equal to order of n. Space complexity is order of n. And the approach is recursively breaking into smaller subproblems and storing, that is memorizing the results to avoid recomputation. Memorizing. After computing subproblem, the results are stored in a table that is called memorized. So normally in Python it uses dictionary or array. And Next one is bottom-up approach, tabulation method. In this approach, we solve the smallest problem first. Here, we are coming from base case to problem case. So, solve the subproblem first and store the results in a table, usually an array or matrix. We then use the results to build up the solution to the subproblems. It's an iterative approach, not a recursive approach. We are using the solution of base case to the next level and finding nth Fibonacci term in Fibonacci series. We will see Python code the next slide. Tabulation is a technique used to solve problems. It uses table where the results to the most basic subproblems are stored. Here we are solving from base case to the problem case. So the base case results are stored in a table initially. Then the table gets filled with more and more subproblems and then it will move to the complete problem. Okay, that is called bottom-up approach. Subproblem to whole problem. Base case to uh, problem case. That is called bottom-up approach. It uses the technique called tabulation. And bottom-up approach, tabulation. In this approach, we solve the subproblem first, then store the result in a table, usually array or matrix. When we use the result to build up the solution to the original problem, it is iterative or not recursive. See the Python code, Fibonacci of n. If n is less than or equal to 1, return 1. Else, here is iteration. It uses array, table of 0 equal to 0 into n plus 1. So the initial value 0 and 1 is stored. Then from range 2 to n plus 1, we are using for loop iterative statement. Table of I is equal to table of I minus 1 plus I minus 2. This ith term is sum of I minus 1 and I minus 2. So the for loop iterates from 2 to n plus 1. Finally, return the table n. Here there is no recursive call. The computation complexity is very less. And the memory space used in this bottom approach is less compared to top-down approach, because iterative approach, there is no need of storing all the results in a separate cache memory. Here in bottom-up approach, it stores all recursive call status in a stack that needs more memory than bottom-up approach. Comparison. Approach, top-down approach, bottom-up approach. Technique, memorization is used in top-down approach, bottom-up tabulation. The process is recursive process in top-down approach, iterative process in bottom-up approach. Storage, it uses cache, dictionary or list in Python. Here it uses list or array. Function call, here it's a recursive function call. Here there is no recursive function call, it uses only iterative looping statement. Stack space. Extra space is required to store the recursive call informations. But here the bottom-up approach, the memory space used is minimal, no recursion. We'll see some examples for dynamic programming. Is mainly applicable for solving overlapping subproblems and to find optimal solutions to the complex problems. Zero knapsack problem, finding nth term in Fibonacci series. In the case of string processing, finding largest common subsequence and matrix chain multiplications. Thank you.